As our second lesson in polynomials today, we're going to look at how to divide polynomials. I mentioned that in polynomials, we're going to be able to factor them or be able to figure out what multiplies to give us polynomials that have a greater power than 2. So when looking at a question that has x cubed in it or x to the 4th, there isn't some step-by-step process like factoring where, okay, what multiplies to give you this or that, and what adds to give you this. It's not like that. In fact, we have to get it to a quadratic in order to factor it, really. So when looking at this particular example that you see right here on the screen, and you look at number 1 in your homework packets, there should be some relationship. In fact, in number 1 on the packet, it said x plus 8 times x squared plus 3x plus 1. And when you multiplied it out, you get x cubed plus 11x squared plus 25x plus 8, as you well know. Well, what if instead I said to you, all right, x cubed plus 11x squared plus 25x plus 8, and I wanted you to factor that, or I wanted you to figure out what was the other factor based on the fact that we know x plus 8 is one of them. We would use division. Very similar to if I said to you, okay, you have 8, and I want to know 8 divided by 4, or I want to, 4 is one of the factors. How would you figure out what the other factor is? Of course, that just means you're going to add, or sorry, divide. So when I look at this question, x cubed plus 11x squared plus 25x plus 8 divided by x plus 8, another way they could ask this question is, x plus 8 is a factor, find the other factor. Knowing that, we have to be able to divide, and we're going to set it up just like division from when you were in 3rd or 4th grade when you learned it. So I'm going to write this all out. And now what I want you to remember is back in 3rd grade, when you first learned how to divide, let's just say 6 and do 192. How do you do that? What do you have to do? You start by looking at 6 times what gives you 19. And so, okay, well, 6 times 3. Then you multiply 3 times 6 and you get, good. Then you have to remember this little key thing. Then you subtract. So 19 minus 18 and you get 1. And then what do? We bring down the next term, and you bring that down, and then you start all over again. 6 goes into 12 2 times. 2 times 6 is 12. And then you subtract those, and of course in this case the remainder is 2. Sorry. Okay, sorry about that. Let's go ahead and divide this. So what I'm looking for is, you're just going to look at that first term and you're going to say x goes into x cubed how many times? X squared. Now x squared, then you're going to take that x squared and you're going to multiply it to both terms. So x squared times x gives me x cubed. X squared times the 8 gives me 8x squared. Now what do we do next? What did you do after you multiplied the 3 times the 6 and got that 18? You subtracted. Now, the trick about this and the mistake that most people make is they forget to subtract both terms, both of them. So the x cubed cancel. You have 11x squared minus 8x squared, and that gives you 3x squared. And then what do? That's right. We bring down the next term. Okay, let's do this again. Now we're right back at the starting point. X, how do I get that to be 3x squared? You multiply by 3 and x. 3x times x gives me, 3x squared. And again, 3x times the 8 is 24x, and it is positive. And then what do? That's right, we subtract, and we subtract both terms. The 3x squared cancels out. 25 minus 24 is just x. Bring down the next term. Okay, how do I get x to be x? Well, you multiply by 1. 1 times x is x. 1 times 8 is positive 8. And, we subtract both terms. And sure enough, we get a remainder of 0. You should always have a remainder equal to 0. if it is a root. So if x plus 8 is not a root, this would have had a remainder. I'm going to tell you, you should never get a remainder. Ever. Ever, ever, ever. Okay, let's see if we can do another one. Let's try this one. X plus 2 divided into x cubed plus 5x squared plus 10x plus 8. I want you possibly to try this on your own. Maybe at least set this up for yourself, and as you get stuck, you can refer back to this video. But I would go ahead, write this down, and then see what you come up with and see how close you come. All right, if you're listening to this video after you've done it, wonderful. That means you've tried this and you said to yourself, okay, x goes into x cubed, that gives you x squared. So x squared times x would be x cubed. X squared times the 2 would give me 2x squared. And then we remember that we have to subtract both terms. The x cubes go away, 3x squared, bring down the next term. And then once again, it brings us back to what gives us 3x squared. And so I'd multiply x by 3x. And that would give me 3x squared plus 6x. And we would subtract both terms. I get 4x, bring down the next term, plus 8. I would then have to multiply the x times 4 to get that 4x plus 8, and I would get 4x plus 8. And we would subtract both terms, and sure enough, we would have a 0 remainder. What does that mean? That means that this is the quotient of that. This is the answer that I'm looking for, x squared plus 3x plus 4. Hopefully you were able to do that. Wonderful. All right, now let's change gears a little bit, and let's look at some factoring again. We don't want to forget this stuff because at the same time as dividing and working with these polynomials, we're going to still have to be able to factor to some level. And if there's an easy way, rather than having to do the dividing piece, we're going to work on that. We really want to do that. So factoring is the easier method. And when I look at this, I want you to think about how can I get x to the 4th? And so, yes, it's x squared and x squared. What multiplies to give me 16? 4 and 4, and the signs are different. Now, if I'm asking you to factor and solve these here, there's a slight issue. This one, x squared plus 4, is done. He can't be factored anymore. If you really want to, you could even at this point set both of them equal to 0 and solve them even right here, even though the x squared minus 4 can solve or factor more. And you can see that this x squared plus 4 doesn't factor. Just when you solve it, you subtract that 4 and you realize, oh, I get that imaginary set of roots. But this one, x squared minus 4 equals 0, when you move that 4 over, you get a positive 4 on that right-hand side. So when you do the square root, it's just plus or minus 2. You'll notice it is x to the 4, so there should be 4 solutions. And there is 4 solutions. 2 happen to be imaginary, and 2 are real answers, real numbers. Okay? Great. Let's look at the next one. The next one varies slightly from the one above it. What do we notice about this one? Good, there's something in common, x squared. And so I'm going to aim for those. Those are things that you really want to look for, ways that you can cut around having to do these extensive factoring or quadratic formulas or dividing. And so the x squared was in common. And this term right here in the parentheses, x squared minus 16, that too could factor. We could write that as x plus 4 and x minus 4. Again, when you solve this, you could have just done that within the solution as well. This x squared equals 0 when you do x equals and you take that square root. Plus or minus 0 is a moot point because 0 is neither positive nor negative. So we don't need to signify that. We just know that that actually represents 2 solutions right there. Good. All right, the next one. I'm going to actually do this one over here to the right. X to the 4th minus 16x cubed. What do you know about that one? And you can see quite simply that 3 of the answers are 0, and 1 of them is 16, and that gets the answer to that one. All right, now I want you to try the next couple here on your own and see if you're able to get the answers. I'm going to work them out here on the board without talking you through it. I just kind of want to see if you can do that. So go ahead and pause the video and try these on your own. Wonderful. And there's the last two answers there. You'll notice I solved them. How do I know that they're asking me to solve in this? Because at no point does it say to solve. The equals 0. Very good. That equals 0 tells me without any instruction that that's what I can do. I can solve it all the way down to its roots. Great. All right. Now, since I'm doing this on a video and there's still a few minutes here, I want to just point out, if I was to ask you x plus y to the 4th power, in the past, what that would mean is you would have to take x plus y times x plus y times x plus y and times x plus y. Certainly, this is not something we really enjoy doing, but it is what we have to do. There is a shortcut, or rather a trick, that we can learn, and we will be learning tomorrow. But I want to illustrate this because I want you to see the beauty of the trick that we're going to learn tomorrow and how many students choose not to learn the technique tomorrow called the Binomial Theorem. They choose not to learn it, and therefore they waste precious time having to do it the long way. If you were to watch me do this and even clock my time, I'm going to just show that I'll start at 12:40. All right. I'm going to multiply these two together and multiply these two together. And so I'd get x squared, x times x, and then I'd have x times y, which is xy, and then I'd have xy here in the middle, and then I'd have y times y, which is y squared. Combine that together, you get x squared plus 2xy plus y squared. That's the first one. Then I would do it again, and hopefully you recognize that it is in fact the same thing, and that saves me a little bit of time. It won't always work out so pretty, but it does. So then I've got to multiply this. So I'm going to do x squared times x squared, and that gives me x to the 4th. And maybe you're willing to do the shortcut in which I showed you. And so you'd have 2x cubed y squared, or sorry, y. And then this would be 2x cubed y. And so together makes 4x cubed y. Plus, now we're going to do x squared times the last term. That's x squared y squared. Move in on both of them. That gives me 4x squared y squared. So I've got 1x squared y squared and 4. And then I move it again and I get another 1. Together, that would make 6x squared y squared. All right, now I'm going to use different colors so we can see it. I've done x squared to everybody. Now I'm going to go 2xy to the end here. That gives me 2xy cubed. Move in, right? I move in, and I get 2xy cubed. So I get, in the red here, 4xy cubed plus, and then the last term that we would have is the y squared times the y squared, which gives me y to the 4th. And that would give me that answer. If you were to look at other examples, you would see that they get quite extensive. What if I said to the 7th power or to the 9th power, and how massive that multiplication actually becomes? Keep in mind that these are not pretty, but there is a shortcut, and I really want you to pay attention to that lesson tomorrow when we get to that. So, okay.